Now the friction and the turbulence in a boundary layer, how does that work? So we know about the friction. We are familiar with this friction. If we rub our hand over the top of the table, friction tends to slow its movement because of the irregular surface in the table. One of the microscopic level in the air, friction arises as atom and molecules of the two surface seems to they're attached or adhere. Then the snap apart as the hand slide over the table. So friction is not restricted to solid objects. It occurs in moving fluids too. If we consider, for example, a steady flow of water in a stream, when a paddle is placed in the stream, turbulence eddy from behind it. This eddy creates fluid friction by draining energy from the mainstream flow and slow it down. So the friction of the fluid flow is viscosity. So viscosity is actually that friction is barring the flow is smooth flow. That's viscosity in the liquid. When the slowing of the fluid such as air it happened due to the random motion of the gas molecule, the viscosity at that moment we call it molecular viscosity. Considering a mass of air gliding horizontally and smoothly, so this horizontally smooth gliding of air is called laminar flow. So laminar flow over a stationary mass of the air. Even though the molecule in the stationary air are not moving horizontally, they are darting about and colliding with each other. At the boundary separating the air layer, there is a constant exchange of molecule between the stationary air and the flowing air. The overall effect of this molecular exchange is to slow down the moving air. If the molecular viscosity were the only type of the friction acting on the moving air, the effect of the friction would disappear in a thin layer just above the surface. There is, however, another frictional effect that is far more important than reducing the wind speed. We call it the mechanical turbulence. When laminar flow gives way to irregular turbulence motion, there is an effect similar to the molecular viscosity, but which occur throughout a much larger portion of the moving air. The internal friction produced by turbulence eddy is called eddy viscosity. Near the surface, it is related to the roughness of the ground. As wind blows over the landscape dotted with tree and building, it breaks into series of irregular twisting eddies, and that can influence the airflow from hundreds of meters above the surface. Within the eddy, the wind speed and direction fluctuate rapidly and produce the irregular air motion, and that irregular air motion cause the gust wind. So the eddy motion created by obstruction are commonly referred to the mechanical turbulence. The mechanical turbulence creates a drag on a flow of the air, one far greater than the caused by the molecular viscosity. So mechanical turbulence is much more important than the molecular viscosity. Another types of turbulence that's called thermal turbulence. So surface heating and instability cause the turbulence extends to a greater altitude. As surface the Earth's surface heated, thermal rise and convection cells form. The resulting vertical motion creates the thermal turbulence. So this thermal turbulence increases with the intensity of the surface heating and the degree of the atmospheric instability. During the morning, when the air is most stable, thermal turbulence is normally at the minimum. At surface heating increase, instability is induced and thermal turbulence become more intense. If this heating produces convective cloud that rise to great heights, there may be turbulence from Earth's surface to the base of the stratosphere, more than 10 kilometers. So, in the summary, we can say friction of airflow in another word that's called viscosity, is a result of the exchange of air molecule moving at different speed. The exchange brought about by random molecular motion, that we call it molecular viscosity. So this molecular viscosity is quite small in compare with the exchange brought about by the turbulence motion that we call eddy viscosity. So we can say the frictional effect of the surface on moving air depends on largely on the mechanical and thermal turbulent mixing. The depth of the mixing frictional influence boundary layer depends on three factors. Number one, surface heating. Surface heating produces a steep lapse rate and a strong thermal turbulence. Number two is strong wind speed, producing strong mechanical turbulence motion. Number three, roughness or hilly landscape. That roughness and hilly landscape produce a strong mechanical turbulence. So when these three factors occur simultaneously, the friction effect of the ground is transferred upward to considerable height. So and the wind at the surface is strong and become gusty. So friction and turbulence has an immense effect on the boundary layer that influence not only the flow, also the wind direction.